Welcome, ladies and gentlemen, to this index session on digital deployment organized by the French Society of Nuclear Energy. I am Jean-Bernard THEVENON, working at the scientific direction of Framatome with 34 years of experience in the nuclear industry, both reactor and fuel cycle. And I am pleased to share this webinar moderation together with Mr. Jean-Eudes Guilhot.
Yes, thank you, Jean-Bernard. Hello, everyone. My name is Jean-Eudes Guilhot. I'm head of the Digital Excellence Center at Assystem. And my mission, among others, is to work on the digitalization of Assystem and support the one of our customers. Back to you, Jean-Bernard.
Okay, thanks. So this session is the sixth webinar of Index 2022 series, made of 9 webinars. 6 webinars are about working session, whose 4 on plant life cycle and 2 on transversal topics, such as the one today, which is on digital deployment. And there are other 3 webinars, which are roundtables with keynotes. So today the digital deployment session is organized as follows. So first we will have a global landscape shaped by OECD and EA, then 4 presentations on practical case studies, which will give you a flavor of current digital deployment in nuclear. And this session will end by a presentation about the digital norms ongoing. So we then have 6 presentations, which is quite challenging for a 2-hour webinar. So therefore I'll ask to all speakers to remain in the time slot of 15 minutes, which allows us to have 5 minutes for Q&A, and also to give the other speaker the right time and to talk in good condition. During this presentation, you have the capability to ask questions by using the Slido button, which is on the upper banner of your team interface on the right. So please use it as soon as you have any question. Don't wait until the end of the presentation. You also have the capability to rank posted questions so that the moderators will be able to ask the question according to this ranking order. I also recall this webinar is registered, and you will have the replay available sooner for registered people and later on the Sfen YouTube channel. Mind also that you have a website and an app for mobile for technical demos. The link given at the bottom of your invitation for today will be activated after this webinar at 4 p.m. So now it's time to start the session with the first presentation.
Yes, so precisely the today's session is about digital deployment, meaning where are we in terms of deployment of digital technology in the nuclear industry? Are we organized to be at scale, yes or no? So, and we are going to have a presentation from Antonio Vayá Soler. So, as Jean-Bernard said, from OECD. Antonio is currently senior analyst in this organization, in the Nuclear Energy Agency, by the way. And is in current position, Antonio, in fact, you are supporting members countries to develop an effective energy nuclear policies, and you also conduct technico-economic analysis. And today you are indeed going to share us with you one of these conclusion or analysis on that very subject. Thank you, Antonio, for being with us today.
So thank you, Jean-Eudes, and also a pleasure to be here in this webinar. And so let's start by sharing my screen. Okay, just coming back. Okay. So what I'm trying to do in these 15 minutes is to share an overview of our work on digital transformation within the Nuclear Energy Agency, our rationale behind that, our motivation, and what we discovered. We also had the opportunity to interact with different member countries and non-OECD member countries indeed, and identify where the challenges lie. Always keeping in mind that we really want to foster a widespread digitalization in the sector, and this is really the main challenge. So our initial point is, okay, we see that nuclear power plants in OECD countries are not delivered on time and on budget. This is the most important difficulty. It's not about the cost itself, it's the uncertainty behind the delivery. So it's trying to how maybe digital tools and other options, of course, other decisions and cost reduction drivers can lead to that. So we really analyzed all the projects. We identify a handful of drivers to get into this positive learning curve, and really we identify that technology and process innovations was one of them. We identify advanced construction methods, but we saw digital transformation. So after delivering this analysis, we said, okay, let's try to dig a little bit more. And our lines of inquiry, the questions that we wanted to answer, were really, as already Jean-Bernard highlighted, where we stand today in terms of digital transformation. It's true that there's a lot of noise there, especially we have to think in policymakers. Our idea is those that take decisions, we have to bring the evidence, help them to understand that this is moving, that this is happening, and then can help to drive costs down. So try to clarify a little bit, tell the story also, and try to quantify to what extent the benefits. This is difficult, as you will see. And then, of course, where the challenges lie and when maybe policies or regulation could help. So if we start with the tracking process, and this is also part of the index conferences, like we started with looking at construction, and then we realized that there's a whole set of solutions over the whole life cycle of a nuclear power plant. So some of them, and this gets to the next slide, of course, is about in which stage of deployment, what are the maturity, and of course, like trying to manage expectations. This is the term. It's like, okay, it's true that some technologies are quite advanced in other sectors, but this does not mean, especially when you get into safety related, let's say, components or systems, that you can apply this directly. And this will come again in my presentation as nuclear, as I will highlight nuclear special. You have to understand where this is so special and how your technology could fit. So it's a matter also to identify those solutions from all the portfolio that are mature and that are quick wins. And necessarily this always happen, and it's already happening when you don't get into maybe things that are not safety related, that you can do a lot of things. Again, when you start to get into the interesting part of safety related systems, when things get more complicated, that of course, since I would say the nuclear sector is not a front runner. It was a front runner at the beginning when we started to do this modeling work, but now we are not a front runner of the digital transformation. However, we can learn from other sectors, and this is always an opportunity that we try to explore. When it comes to quantified benefits, and when you look at the cost of nuclear, it's true that a nuclear power plant, existing one, in most of the jurisdictions is already, let's say, competitive, but focus on construction. If you really have digital solutions that allow you to deliver more predictably, this will have a huge impact. Also how investors will perceive this. So this is a huge economic advantage. And of course, when you look at the cost of nuclear power plants, you see that most of them are indirect cost, which means cost associated to the project management, to the organization itself, to the reworking. So think that if you have digital tools that allow you to design better, to take those decisions on site when it's needed and faster, well informed, this can reduce indirect cost and have most of the economic impact. But then we get into the details. Can we measure this? Sometimes it was not easy. It was easy for us to identify opportunities, people telling us, yes, we do things in a shorter time. We collaborate more, but we cannot quantify because sometimes we don't have the reference case. Just imagine, it would be ideal to have a nuclear power plant that has been built with our digital tools and compare them with another one that has been fully deployed with digital solutions, and then you compare them. We don't have that. Maybe we will have, and we could measure. Then most of the aspects are intangible, which means, okay, you may create a better environment for collaboration, another culture for innovation, things like that. It's difficult to factor in the return of investment and to do a compelling business case. And of course, these benefits take time. And most of the organizations are driven by short-term objectives. So we don't have really the tools to seize all these benefits. So this makes difficult, really sometimes difficult to measure, sometimes not, but in most of the cases we saw that it was the cost reduction itself did not come out so easily. Another thing that we observe is about it really makes a lot of sense to embark in a full digital journey if you really have different in front of you different units. And I can cite the example from Canada, Ontario, PG, telling us we have a refurbishment of 6 units. This makes sense for us, which means that, of course, at the beginning, you will have a non-recurrent cost of deploying that. So it can be expensive, but then the story behind is maybe your learning curve is faster than without the digital solution. Why not? But this is what it came from the discussion. And now, just moving to the challenges, the thing is that when you go to digital transformation, reality is the organization and the user, in fact. And I will try also the supply chain, and I will try to illustrate this with 2 small examples. And this is one coming from our colleagues from Framatome, and it's about the geotags. And we can be engineers, we can imagine a lot of solutions. Yes, they wanted to track workers in different countries on site to improve, make leaner all these movement flux, reduce cost, also increase safety on site. Okay, looks perfect to track workers. What happened in reality is that workers don't want to be tracked. So they took the helmets, they put them on the docks, they piled them up, they do whatever they wanted, not the expected result. So they had to change the solution, and they decided to use video analytics instead, just to illustrate how it's important to include the user experience. And another example we have from our colleagues from the United Arab Emirates, for instance, not an OECD country, but what has been successful recently with the Baraka project is about extending the benefits to the whole supply chain, working as an extended enterprise. This is more as a framework, but what they were trying to do is to also trying to talk a common language with some suppliers. So you go there with a solution and they understand you, share the benefits, have the rules really clear how you will exchange this information. So this is when it gets hard, and this should not be really underestimated when you are deploying a digital strategy. The user and the organizational aspects to interact with the supply chain, because really you get most of the benefits of a digital strategy when you extend it over your suppliers, but this is the hard part. And here I list it, and I will try to finish, where nuclear is special. When it comes to these dimensions, really data access, okay, now there are opportunities of integration, data lakes, working with data, but we are not a data-driven or oriented organization. We work by métier, by silos, connectivity is limited, so you see a harder. The timelines, digital goes faster, we go slow because of qualifications. We cannot take advantage of standard solutions because of sovereign and control. Our culture is not the same because we are driven by quality, and we have to do right the first time, which stunts a little bit creativity. So you can see the difficulties here. And of course, in terms of cybersecurity, we have a higher standard. So regulators, what can they do? And really, they have to be part of the game. If not, we cannot get the full benefit. It's very simple. They are an enabler. And I take the framework from ONR UK because I really like it. You can see how they are adaptable. They divide their approach according to the maturity of the technology on the X-axis, but also according to the regulatory readiness level. There's a framework, we know about this or not. And depending on this, they adapt, and they also, and I like this one especially, about higher readiness level, a framework does not exist, which means that we have to put all the people together in a sandbox, in an experiment. So pilot projects, a small case. This is critical to accelerate the deployment, really into also safety critical parts. So my key takeaway message is we are moving, but this is only the beginning of our journey. The economic rationale behind also, it's improved if you have several projects. Maybe with SMRs, it gets better. Maybe with a large nuclear program makes most sense. And also just focus on the organization, focus on the data, on the governance of that data, how it has changed, the rules, consider the user, and start working with the whole supply chain. And of course, map where how you are different compared to other sectors, and really take that framework in mind when you're trying to implement something and trying to change the organization, and input all of that into the business case, into the cost, because there are some costs that just to do a business case that is more realistic. And of course, regulators, different culture, different approaches, but of course a key enabler to get into, as I said at the beginning, widespread large-scale use of digital in the nuclear sector. So with this, I finish. Hopefully I had it on time. Thank you.
Thank you very much, Antonio. Very interesting landscape, by the way. And I like the Gardner curves. I think everyone can have the same feeling sometimes on our project. There is one question, and by the way, I remind that any question can be or have to be raised on the Teams using Slido. This question is, Antonio, about ONR. I'm not sure if you can answer, by the way, did ONR develop their initiative on their own? Are their formats, I guess the information you gave us, to spread into other countries?
I mean, this is indeed our role. I mean, you have to understand when it comes to regulation that, as I said, there are different approaches, different cultures, and sovereignty aspects that are so political that cannot be changed. But this is our role as an organization to come to put all the people on the same table and identify these areas where there is a common understanding. So if I'm getting this input, I'm pretty sure that other regulators are really aware of this. Now then we share it, they got the information, then it's up to them to digest it and at some point adopt it to what they say. But it's something that I would say is happening in the UK. They have an approach, they call it, to regulate innovation. They understand that they are a key enabler for that, and that will not happen without them. They try to be proactive in a sense that they try already to assess what is happening there. And most importantly, they try to build the capabilities internally. This is also important because some of these solutions, you go to the regulator and people don't understand. You don't share the same language. So they are a little bit in advance, I would say. But of course, there are still differences between countries, and our work is here and in an international organization to share practices, and then countries decide what they do.
Another question from Xavier, which is a good one. The question is, how can we justify large investment in digitalization when benefits are so difficult to measure, as you rightly said in your presentation?
Okay, there are two things. Either people that have to invest get it because they have already seen this work in other sectors, even they don't get it, but since it's intangible, at some point you have to tell a story, and you have to convince them, I would say. But what really improves the rationale, as I said, is having a program. And I said again the example from Canada. For Bruce, they were refurbishing these 6 units, and they clearly told us it makes sense up to the X number of refurbishment. We see cost benefit. So we invest at the beginning maybe we don't recover, but after the X number of refurbishment, we see we do it cheaper thanks to that investment. So again, it improves the ration, something that really improves the logic of that business case, especially, I would say, large digital programs, especially across the supply chain, is to have several projects. The programmatic approach makes a lot of sense because it's also an opportunity to deploy them. You deploy them and learn, because just imagine you only have one single plan to do that. It's too much burden for, for a whole digital strategy. So, yeah.
I think conviction is a key word, by the way, because I believe that, that some projects have to be launched by conviction in the first place, and then we see. Maybe Jean-Bernard, I give you back the floor for the next presentation.
Yes, thank you, Jean-Eudes. Just two things I noticed first during this presentation from Antonio is that I noticed that technology and process innovation can bring short-term benefits. Okay, but have you seen any comment about the need to review process? So I had just one question for you. Digital transformation, okay, but if you don't review the process, some process, you may fail. So in your inquiries, is it a topic? I mean the process review.
No, I mean, it's not the topic, it's the topic. I mean, it's just, as is what I try to say. The digital, I mean, and you all know this, but I say it again. The digital transformation is, I mean, we have a lot of tools, but this is what we try to convey to the policymakers is all about I mean, when I say organization and user, is because they are engaged in the process itself. So yes, you have to rethink the process and how the user interacts with that tool to get the good marriage of that. But of course, the higher you re-engineer the thing, the higher the risks too. So again, it makes sense to have several projects to accommodate that and to improve the economic sense, because maybe in one single project, you cannot recover that risk or investment. So everything is interrelated, but as you mentioned, process is key, is most of it, in fact. And if you just pile up tools, you don't get anywhere. You have to do it in a way where the processes and the user and the tool all come together in a, I would say, more effective way. And the digital transformation is an opportunity to review the process.
Okay, thank you, Antonio. Now we can move forward to the next presentation, which is a presentation made by Mr. Sfen. So Sam Sfen is a chartered civil engineer with almost 2 decades experience working across the nuclear industry and wider in energy sector. So Sam leads the digital transformation at the SNC Lavalin nuclear sector and works with teams around the world to support internal digital capability development and also with clients seeking to integrate digital solution. So Sam, the floor is yours.
Merci. Thanks very much. Good to talk to everyone today, and good afternoon. So I'm going to share some of my experiences of delivering some of the changes that Antonio talked about there across SNC Lavalин's global nuclear business. We work across around the world, supporting clients right across the nuclear life cycle, working across nuclear generation, nuclear decommissioning, and on new build projects, and particularly in across Europe, Canada, and the USA. One area that is particularly important to us is actually looking ahead to the role of digital in nuclear, and we've recently published a report which sets out our vision for 2035. Now, it's very much written in a UK context, but I think everything that we've written about there is applicable right across the world, and actually drawing upon some of the points that Antonio made in the role of digital at every stage of the nuclear asset life. We're seeing benefits from adopting digital approaches right across power new build, nuclear new build projects, Hinkley Point C, for example, intergeneration, where we're working on refurbishments of the CANDU reactors that Antonio referred to, but also supporting EDF with their nuclear generation fleet in the UK. But then also into decommissioning, where we're helping solve complex decommissioning challenges. And in our report, we identified 5 key technologies that we see as being important, that work right across the project life cycle, and will start to underpin what we see as being the future for digital industry. If you follow the QR code, you can find our report or Google it, and you'll find it there. We also identified in the report four key barriers to adopting digital solutions across nuclear today. And I recently ran a LinkedIn poll amongst my network at the end of November, and this is the sort of feedback that I received, that there's still a resistance to adopt new technology, and some of the legacy business models that are in place kind of stand in our way. One of the comments from my network as well is around the standards that we have in place as a common language and common understanding, which in many ways is the kind of root cause for many of these issues. I think in terms of when I look at the challenges that we face in getting kind of digital solutions adopted by teams across my business, but also across the wider industry, one observation I'd make is that you can't beat the innovation diffusion curve. And I'm sure you'll all be familiar with this idea that innovation starts and get adopted by the innovators and the early adopters, and then when looking to scale and roll those out further, then the key thing is obviously getting that majority on board. And one thing that I've found is that getting change to happen amongst communities like this, which understand the issues, understand the technology, are keen to try things, that's dead easy. But actually getting the majority to adopt new ways of working, new solutions is the really hard bit. And in that respect, one thing I've observed is that it is very difficult to go very much faster than where the rest of the industry is. We've seen that there are opportunities where you can move ahead and lead the industry, but you go too fast and you end up burning money ahead of that market pool. And there are obviously opportunities where taking that kind of first follower and catching up fast approach is a strategy, but there is also the risk that you go too slow and are disrupted. And I think for me, with all conferences like this, it's really important to actually kind of share our knowledge and learning to collectively bring the industry forward, to create the opportunities to engineer a better future for our planet and its people. Just kind of building on that, when we work with teams and I work with clients in terms of with the adoption of digital solutions, I face a common set of challenges. And if you go to the QR code, you'll be able to provide your feedback on these challenges that we see. So, for example, I regularly get asked, "What's the ROI? How much am I going to save with this technology? How does it work? What are the benefits from it? How are you going to deliver this?" And finding that first customer to take a leap of faith in quite a conservative industry, sometimes not willing to adopt new solutions, and particularly new solutions where you may not have done it before, and therefore you cannot fully justify that ROI. Now, I don't know whether this poll is going to work. If anyone's able to go on pollev.com and enter those details, you should on the screen hopefully be able to see the feedback from the audience, and if it doesn't work, then maybe we'll come back a little bit later and see whether we can get that to work during the questions. Aha, yes, there's one early adopter who has who's managed to make it work. But that's kind of some of the challenges that I've commonly seen across the sector, and we've got another managed to get it to work. Yeah. Okay. Just give it a few more moments. And of course, if there's any challenges that you've seen, then feel free to share them in the chat or on Slido. And it'd be great to hear your perspectives and also continue the conversation after the call as well. Okay, I'll move on. Thank you. Thanks for your it's really everyone's really got it working now. Good. Okay. So putting in place processes for things you've never done before is the top result there. And I think that aligns to some of the things that Antonio was saying earlier as well. We can move to the next slide. Now, in terms of addressing some of those challenges, I thought I'd share kind of some 3 or 4 things that I see as being important. And this quote I regularly come back to from Jeff Bezos from Amazon around setting strategy for a long term. And often he's asked, okay, what's going to change? And actually, the more important thing, and particularly for us in the nuclear sector, is what's not going to change. What can we look ahead at 10 years' time will always be the case, will still be true, and how do we then plan around that, and how do we hang our strategy off that? And I think having that mindset is really important, particularly for the sector we work in, which is a very much I see it as a long-term sector. We build power stations for 40, 60, 80. New power stations will be for 100 years. What are the fundamentals that we need to put in place over that time frame? The next key thing that I often observe is that people focus first on the technology, on the software, the solution that they want to implement. I get asked, okay, what's your common data environment? Are you using Autodesk? Are you using Aviva? Are you using these various software packages? And a lot of people then are forgetting that actually really the first things to put in place are the people, the training, the skills that you have, and having them aligned and working to the processes that you're going to follow. Alignment with the standards, and then from there, what is the technology that we need to support that? You know, what is the solution architecture, and the people, process, and technology kind of very much. Antonio talked about it in terms of the users, the organisation, and the technology. And I completely agree with him there in that respect. That in order to make these solutions work and make them land, we can't just focus on the shiny new toys at the end of it. We've got to think about actually how we implement this and deliver value throughout the project life cycle. We're also, particularly from kind of the digital software community, starting to see the value of agile ways of working. And sometimes I see that in projects that seems like an excuse to avoid producing a plan and avoid doing the hard thinking as to what you're really going to do. But there are really many good examples of where actually agile and lean scrum type approaches can really add a lot of value. And it's particularly in this space where you've got kind of unclear requirements, you know, a yet to be defined problem, and a yet to be defined solution. And actually then as you move into kind of a clearer space, then more traditional waterfall approaches that we're used to delivering to, particularly in the nuclear sector, often the best approach. But one thing I have noticed that particularly with software and delivering projects with an agile approach, is everyone needs to be joined up in order to deliver in that way. Procurement teams can't go asking for detailed deliverable plans and programs and schedules when you're working at an early stage in this area, in order to underpin the contract. So everyone in the project team, right from the project managers, the engineers, through to the procurement teams, need to understand those ways of working. We're seeing a huge amount of value from looking to other sectors to bring solutions that are mature. Robotics is a great example of where we're seeing a huge amount of value at the moment. The robotic solutions are mature, readily deployed in automotive, advanced manufacturing, and in more and more sectors in logistics and healthcare even as well. And by addressing some of the challenges there, that they're becoming more reliable, more proven and tried and tested. That now the challenge is not around can we nuclearize these solutions and gold plate them, but can we adapt what is there and bring them in with a pragmatic, smart understanding of the nuclear safety case and get them to work. And that's true for quite a number of solutions. Robotics is a great example, but we're seeing that with cloud solutions and adopting cloud computing, cloud storage, machine vision, laser scanning drones, and also in the building information modeling, the BIM community coming from the built environment, seeing a huge amount of value in adopting those to support both new build but also decommissioning projects. Just on the timing front, often it's easy to delay the adoption of new technology and wait for it to come down in cost in order before you come on board. But one thing I've noticed particularly with generation stations is that the sooner you adopt digital solutions, the earlier that you can reap the benefits from them. And even when then the station is shut down, we see a huge amount of value in the information and the knowledge gained and the process and procedures put in place in order to transfer that learning into decommissioning. And so the earlier you adopt, the earlier you get on board. Obviously, once you have reached that kind of equal cost benefit, then the more value that you can reap from it. And then I think the final point I wanted to make, and hopefully this video will play whilst I speak, is that you really need to be open-minded around whether you're going to pivot or persevere at some point. And for us, over the last 2 years, we identified kind of an initial pain point around the sharing and viewing of very large data sets that we capture on sites from laser scanning, from drones, from 360-degree imagery and cameras. And with those pain points, our clients and our teams were struggling to view them, but also share them. And so over the last 2 years, we've rolled out a solution, kind of bringing in a lot of what I've talked about earlier around agile ways of working, around focusing on the customer. But we also have learned that actually our original hypothesis around what the pain points were, actually where the real value in a solution like this is not just around sharing the data, but it's actually enabling what we call virtual site access. So it's where we have remote sites and where actually the real pain points are around teams getting to sites and the cost and carbon associated with that. And so being prepared to experiment, to test and learn, and then move into a different either continue on that track or be prepared to pivot is really important. So I was just going to conclude, and with obviously the points that I've made, I think it's important that you take a very long-term view, think about what's not going to change, focus on the people, the process, and the technology in that order. Consider agile ways of working, but also make sure that it's in the right solution maturity to adopt those types of ways of working. Look to other sectors. I benefit from working with teams across nuclear, but also across many sectors that SNC-Lavalin works across around the world. Recognize that actually by investing early, you can get benefits right throughout the asset life cycle. And don't be afraid to change course. It's very easy to try and set out a direction for the next 10 years, and actually you learn a lot just by adopting and deploying new solutions. So thank you very much. Thanks for your time.
Thank you, Sam, for this very interesting and clear presentation. I personally love the schema about the problem space and the way the agile method could help. I have some questions, but there is one question on the Slido. So I would like you to be as fast as possible because we are just on time. So there is a question from Claude. In the presentation, it looks that one should be heading to benefit at most. Aren't there also some risk of failure in heading the digital world?
Yeah, great question, and I think that we have to accept risks of failure with anything that we do. If we don't accept any risks of failure, we won't move forward and achieve anything. And I think that one of the key lessons I've learned is actually for those first steps is to make that risk as tolerable as possible, either through adjusting the time or the investment whilst you prove that solution. So, you know, for kind of early stage in investments, we should be looking at what can we do and learn in the first 6 to 8 weeks to prove or disprove that idea, and from there then progressively invest more. And in that respect, you take a kind of an incremental approach to investment, but also an incremental approach to kind of managing risk, and that trade-off. And obviously then you minimize the pain from failure. And I think as an industry, I think we are obviously very averse to failure. But I think actually we need to look at, in order to adopt digital solutions, look at how we can fail fast and fail safely.
Okay, thank you, Sam. I had 3 questions, but due to the time, I just ask one very quick. You were working worldwide on digital transformation, and do you have an idea of what part of the world or which country is the best advanced in digital transformation? Is there any region where things are going faster than in other places?
I think there are very much differences. You know, when I look across those technologies, some regions progressing much more quickly than others. I think it depends, but I think one good example that I come back to, particularly with adoption of building information modeling and international standards like ISO 19650 for sharing information. I would say that I think the UK, and I obviously I'm British and I'm biased, but I would say that the UK has kind of set itself apart, I think, ahead of other countries in adopting that. And I think one of the key lessons learned is that 10 years ago, the UK government mandated that all projects should be at a certain level of BIM level 2 by 2016. And I think this actually really was a really important catalyst for driving forward kind of the UK industry. And now when we talk to clients in the US and Canada, it's very much a case that we're bringing kind of the UK experience from the BIM community to help them. And so I think that the question is more about than actually how how can governments and mandates tied to infrastructure investments support the digital changes that we want to see?
Okay, thank you, Sam. We are a bit late, so sorry, Jean-Eudes, but now I give you back the hand.
Thank you very much. Thank you.
Okay, thank you, Sam. And by the way, Sam, you have been very innovative in proposing a pool across the Sfen conference. I think it was the first of a kind, and so you took some risk.
I did.
You took some risk, and it works. It works.
Thank you.
Okay, so the next three, in fact, presentation would be around the different use cases. The next one being the digitalization of the surveillance processes in the nuclear manufacturing within EDF. So welcome Xavier Fargeix for that presentation, and Faiza, Sefta. Xavier, you have been working more than 10 years in nuclear engineering, and you lead the project transformation called Switch MF, manufacturing exactly, and you are together with Faiza, which is Deputy Transformation at EDF Direction Industrielle, working on the Manufacturing Surveillance Department. So it's yours now.
Yeah, hello everyone. So we are very pleased with Faiza to show you a concrete transformation currently ongoing in EDF related to some nuclear aspects, manufacturing of nuclear equipment, which is a very sensitive part of our activities related to our large project, as you have seen in the past with Flamanville 3 or HPC, for example. So in that presentation, we will illustrate, in fact, some points raised by Antonio or Samuel. So it's very linked with the previous presentation. So it would be a good opportunity to share it. So as you see, I'm the project manager, and Faiza is part of the transformation team. And we are very pleased to talk about that now. So very basically, as an introduction, so EDF is leading a major project to transform its manufacturing surveillance activities. You know that for nuclear projects, we are in charge as a final client or final operator to perform some surveillance required by the regulation to be sure that equipments are in line with our quality standards and technical standards. So when we say manufacturing surveillance activities, it covers activities to ensure that quality and safety of the equipment manufactured by the supply chain. There is a documentary aspect. For example, we perform some checkings on welding books before manufacturing or NDT procedures. And also we combine this documentary surveillance with in-factory inspections. Okay, there is key dimensions of this transformation. We want to change radically the way we do our surveillance. We want to change our internal processes, and we want to change our tools and to implement a digital approach through this project. So our project covers the three aspects. So today we share with you this project. Okay.
So yeah. Thank you. Before we go into the project itself, we just wanted to present very shortly our manufacturing control processes. So as the project asks us to intervene in surveillance activities, we typically build a surveillance offer. And one of the transformation aspects of that is that our surveillance offers are now more based on a risk approach to define the surveillance activities that we will do for the manufacturing of a specific equipment. This surveillance offer is then scheduled, and it becomes through scheduling it becomes activities that are done by the different actors. So whether it be a document surveillance or in-factory surveillance, and then this is carried out throughout our plants. At the end of the process, we finalize what we've done, and so a clearance note enables us to have an activity report for the project and indicates everything that was done. Throughout this project, we have interfaces with the outside some outside stakeholders. So it could be, in some instances, the project, of course. So all of our colleagues that are working for the project and that we're supporting through our surveillance. And it could also be, and this is very important, our interactions with the different suppliers. Interactions that are very important to exchange schedules, findings, non-compliance points. We started the transformation and the deployment of this transformation in 2020. An important point is that we started with only the scheduling aspects and the in-factory surveillance aspects of our transformation. The other point is that we didn't start with all of the actors at the same time. We had a smaller pool of contributors during this this starting phase in 2020 and 2021. And then last year was the first major deployment stage and rollout of this transformation, which concentrated on our processes that are inside our organization. And so the future stages will also look into, and we're also building right now the processes that have interactions with the project or the suppliers. This is something that's being developed today. And the first stage of rollout was onboarding our 400 staff and contributors on all of the processes that are inside our organization. So that included surveillance offers that are based on risk analysis, race-based analysis, factory surveillance that's directly carried out on site with the mobility platform, having a consolidated view of our activities and KPIs, and optimizing collaborations between the different actors. A final important part of this transformation is that through it, we're going from a very document paper-based approach to surveillance to a more data-centric approach to surveillance, which in itself is a big transformation point.
Okay. So we want to share with you the key lessons that we have learned through this project that has been, for a part of it, already implemented, as we discussed. So the main benefits to implement a digital transformation and end-to-end digital continuity of our internal processes in terms of business value are very common and basic, but it's important to share it. We confirm that. So the quality of the data, we work through various processes that need to have a very high quality of the data to be sure that we are in line with our expectation requirements. The output also of our processes has to be very clear in terms of information. So we significantly improve our data quality, and it's very important to be noted. The second main benefit is the capitalization of the knowledge. In fact, through all the data that we provide via our processes, we are able now to capitalize, and it's a very a key point because we are able through this capitalization to be more accurate in our future activities. We are more relevant in terms of manufacturing surveillance, and we are able to make the right choice in terms of sending, for example, the inspector to the right operation to survey the right operation for the supplier. So it's very important for us to have it. Also, a main benefit is related to traceability. We have much more vision of our traceability data. So it's a very key point and a very key value of our approach. And also you have some very basic features to manage your activities that we have not before. So important to note also that we are able now to manage much more better our surveillance activities via online dashboards, because we are 100% data-centric oriented. Standardization now, Faiza.
So the second lesson learned is the importance and also sometimes the difficulties of standardization. All digital transformation entails clarifying the processes and also standardizing them throughout the organization. So for each task, role, and process, standardizing is something you have to do, and it's also important. So we had to define, that's the first point, we had to define the responsibility assignment matrix. So typically to define specifically that it's the material engineer that will define the surveillance program at the start of manufacturing in the surveillance offer, and then it will be another actor in this instance called the activity pilot that's going to coordinate and schedule the operational scheduling of the activity. So defining this very precisely was important, and defining who does what was a very important part. It was the first step. This is just an example. Throughout the processes, we had to define these aspects and also standardize them, because different teams were not necessarily working the same way. And that was the first challenge that came with this, which was the need to define this throughout a very large array of manufacturing equipment. So the equipments we have surveillance are go from small electronic equipment to huge equipment such as like steam generators. And even though this array is very large and the people behind them have very diverse backgrounds, technical backgrounds, and also experiences, the transformation needed for a more standardized approach. So the way we went about this is that no matter which equipment we were looking into, we defined a risk-based approach to defining the programs. So even though the equipment might be different, the process is the same, and all equipments have now surveillance programs that are based on a risk-based approach. And this risk-based approach looks into both the equipment risks and manufacturing processes, but also the supplier risks, because we take into account our supplier experience. And then finally, even though we put in a big effort of standardizing the processes, in the end, you still have to adjust for specific circumstances. Not all circumstances will fit in perfectly into the standardized approach. And so agility in that regard is very important. And one aspect of an example of this is that most of our inspectors are roving inspectors. So they move around, and we based our processes around this hypothesis. But we do have some in-factory resident inspectors that have 24-hour schedules and 2-hour notice. In that instance, it doesn't work for the activity pilot to be the one who's standardizing, who's scheduling the activities for the inspectors, because he himself does not work on a 24-hour schedule, obviously. And so we had to adapt the process for the resident inspectors who have some leeway into being able to schedule their own activities. So this is the second takeaway from our transformation rollout, is really both the importance of standardization, the difficulties that come with it, but also adapting to specific circumstances.
Okay, thank you. So an additional lesson learned is about methodology. So we used, as discussed before in the presentation of Samuel, we used we set the delivery of the digital transformation based on the scaled agile framework, the SAFE approach organization, and we implemented some solution based on Dassault System solutions like 3DX platform, Apriso, which is a manufacturing execution system, and some internal application for tablets for the mobility part of the project. Okay, so the key insights that we can share with you, the main challenge for us was to establish a close cooperation between business teams, including end users and managers, of course, and IT teams from editors, from integration teams. We have to internally, from a business point of view, we have to dedicate a team to lead the project and to work closely with all the stakeholders. We had to be focused on the MVP and we have to don't forget the next step beyond the MVP, because the MVP approach is for us in some nuclear processes can be limited. So we have to think MVP, but we have to think also additional steps beyond. We have to day-to-day balance between business expectation and software development and solutions. It's not easy to manage day-to-day because we have to find the right balanced solution. And we have to work between editor standards, what we call the out-of-the-box approach, and the customization needs asked by the end user, for example. So we have to balance between the OOTB approach and the customization needs that we face. Okay. And last, maybe you can go quickly through the change management.
Yeah. So
yes.
we're pretty mature in our.
No more time.
Oh, okay. So very fast, because we're already well into our rollout. We also had some change management aspects that we wanted to share with you of what we've learned. One of them is to have some early adopters, but also quick wins through an MVP approach. Another one was to have a very strong management support at a strategic level, because and this has not been said so much until now, it's actually very difficult to manage tension between the transformation workload of rollout and the operational business as usual activities. And this is a point that we've learned a lot about. And then finally, the last point is to have a high quality support for our early stages and training, because first impressions are very important.
Okay, we are okay. So we are free for some questions, maybe, if we have time.
Yes, yes, we have some time. In fact, there is a certain number of questions. Thank you, first of all, Faiza and Xavier, for the presentation. The one question which is interesting, all questions are interesting, but the one is on safety. Safety authority is involved in the process.
Okay, so safety authority, the French safety authority is aware about this project because we share it by the end of 2021. So they are aware about this and they are interested about this program. They have also question or interest about their own digital transformation because they want to work through that pathway. So they are interested about what we are doing, but there is no direct, link between our transformation program and some safety authority activities. Not direct link, okay. But of course, what we are doing is to be sure that equipment will be manufactured in line with our standards in terms of safety and quality. So at the end, the goal is to reach safety authority expectations. Is it okay?
Mm-hmm. Yes, and another question is, to explain the risk analysis process and the level of automation involved, if any.
Okay, I let Faiza answer. Okay.
So the process itself is to take into consideration what equipment is going to be manufactured and who and where it's going to be manufactured, to take into equipment all of our previous experience of these equipments and maybe some innovation aspects of it that come with it, and to consider all of the risks that are involved in the manufacturing process. These risks are both because of the process and the equipment's specificities. There are also some risks linked to where it's going to be manufactured and our knowledge of how the supplier knows these processes. So for each risk that is identified, we target the level of severity of an impact, and then we define what surveillance activity is appropriate to address those risks. That way, the surveillance activities and programs that we do, whether it be in-shop or document surveillance, is targeted for specific risks and the most important risks. One aspect that we haven't gotten so much into is that we're also looking into more and more surveillance and equipment manufacturing activities, just in terms of volume, because more plants are being built. And so we need to be able to address that through a risk approach and basically targeting our surveillance on the highest risks. And so we've rolled out that in terms of intellectually and a lot of engineering hours to define all of the risk analysis and standard programs. Those standard programs are then digitalized in the solution. So we're working on the rollout of that part. And once they're digitalized, it enables a capitalization and of all of that knowledge, and then also a quicker use of this analysis, because the tool can then be used to make it's a first-based approach for a new surveillance offer that can then be adapted to specific conditions of the contract.
Thank you, Faiza. And just additional information related to the first question. So we had also exchanges with the UK Safety Authority, the ONR. So they are aware also about this project, and we have been audited on this specific point in 2022, just to be exhaustive. Thank you.
Thank you, Xavier. I think we have to move forward. Due to lack of time, we cannot take all the questions, but maybe we'll come back on that at the end. Jean-Bernard, I'll give you back the floor.
Okay, thank you, Jean-Eudes. So now we are moving to the next presentation made by Mr. Evano, François Evano. So François is part of the Metroscope business team. He leads the strategic marketing activities of Metroscope. He is based in Berlin, and he has been involved with customers both in nuclear and conventional power generation in France and in the Benelux region. François has worked also on the Horizon Europe consortium that Metroscope is expected to lead in the field of cooling system monitoring. I must add that at the first Index conference in 2018, we had the presentation of the brand new startup named Metroscope, and I am glad to see that 4 years after, and in spite of the pandemics, Metroscope is still there and quite in good shape. So, François, the floor is yours.
Well, thank you, Jean-Bernard, for this introduction. So I will now show you my presentation for the day. So the point of this presentation today is going to be first to talk about Metroscope itself, what is the company, how it was born, and how it ended up being quite a successful story. So this is an important part to introduce first who we are, what we do, and where we come from. We will also spend some time talking about the technology itself, the software which is behind, because it's also part of why it's been so successful. And finally, I will show you the main example of a deployment of Metroscope at scale, namely on the French nuclear fleet, so the 56 reactors, which are now equipped with Metroscope. So since the last time that Metroscope was introduced here, there has been quite a lot of things happening at Metroscope. So who we are at Metroscope, first and foremost, we are an EDF startup. Metroscope is a spin-off from an R&D project which was aimed at optimizing the monitoring and diagnostics of the EPR reactor, but then the potential of the solution was identified to be applicable to basically any pressurized water reactor. So now we are actually 5 years old and going strong. We have 3 locations, the main one still being in Paris at the moment. We have an office in Berlin, as I'm located, and also, since more recently, an office in Washington, DC, to address the North American market. In terms of our coverage of the market, we are already quite strong in a way, since we already have 68 assets that are equipped with Metroscope. Mostly in terms of nuclear power plants, we have the 56 nuclear reactors, but we are also now gaining a lot of traction on conventional power generations, especially combined cycle power plants, because there's a lot of overlap technologically wise. And we saw that the potential of the solution was not just for nuclear, but also for the rest of power generation. In terms of the people working at Metroscope, we have also set quite a strong milestone quite recently, having more now than 50 people, most of them being data scientists, process experts that really know how a nuclear power plant is working, and obviously also software engineers, since we are actually developing a software. So Metroscope is actually quite a technical company. Just a couple of KPIs, a couple of numbers that we want to emphasize usually when talking about Metroscope. The first one is the amount of losses that we were able to detect in 2021. This amount to 3 terawatt hours of electricity losses on our customer power plant, so 3,000 gigawatt hours. This is the kind of numbers we're talking about when it comes to Metroscope. We are helping operators gain these electricity back. So this is the first number. The second one is the reliability of the solution. And this is especially important in our field because we are offering diagnosis. So we are trying to explain the state in which a power plant is operating, which means that if you don't have a reliable diagnosis, you just cannot act on top of it. So 90% reliability rate is a very, very strong number in our industry. And it means also that the results can be trusted and can be acted upon on a power plant. So we will come back to it a bit later. And finally, a quick mention also to 2 of our main partners, the first one being Framatome. It's quite obvious we are part of the EDF group. Framatome is one of the largest nuclear OEM. So we have a common interest to go at the market. So we collaborate with Framatome both commercially and also technically to be able to expand Metroscope not only at EDF, but also to all of the customers from Framatome. And our second partner is Microsoft Azure, because in the end, Metroscope is a SaaS. We are a software as a service. We are deployed in the cloud, meaning that we leverage a lot of the services from Azure, especially when it comes to cybersecurity. It's been mentioned numerous times. This is quite a big issue in the nuclear industry. And for this, we have a strong partnership with Azure. And it also comes down to working with data management. So we are quite proud to collaborate as well with Azure. Just a few references also for you to see who we are working with. EDF is still, will probably remain for some time, our biggest customer. We have all of the French nuclear fleet. We also recently equipped Sizewell B in the UK. And we are also in the way to equip the thermal fleet of EDF, namely the plants from Blénaud, Bouchain, and Martigues in France. So we are expanding in nuclear as well as in thermal. We also have other clients aside EDF in Europe, in the rest of the world. So we see some good traction when it comes to Metroscope. Now, what is it about exactly? Just before I talk to you about Metroscope specifically, I just want to set the scene. Metroscope is a software for monitoring and diagnostics of power plants in operation. So we're not talking about new build, we're not talking about decommissioning, we're really talking about plants which are operating right now. And what it means, monitoring and diagnostics for these plants, it means for us 4 things. First one, you need to collect the data. If you want to understand what's going on the plant, that's pretty obvious. You need your data. The nuclear industry is quite good in this regard. It's well instrumented usually. Data is collected, it is stored. So this is not a key concern. What comes after is a bigger concern. Now, once you have the data, you need to have some monitoring. You need to have someone looking at the data, understanding what is going on the process, and potentially detect what could go wrong on the process. This is what we call an anomaly. Once you have an idea of an anomaly, it can be just the sensor data which is going wrong. Maybe the sensor is drifting. Maybe there's actually something going wrong. So you need an extra step. You need to provide a story, an understanding exactly of what is going wrong. And this is where the diagnostics step in. This is where you need to provide an understanding of what is wrong with the process. And this is really the key expertise of Metroscope, and we will come to it a bit later. And once you have a diagnosis, you have the basis for taking a decision. It can be a maintenance action. It can be also an arbitration in terms of how you run the plant for some time. You can decide, for example, to leave a fault as it is for the next outage, or you can decide to act quickly, even sometimes trigger an unplanned outage because you know you have to solve this issue now. Otherwise, the cost is going to be too big. So this is the whole process that we have in mind when we talk about Metroscope. And now we're going to focus more about what kind of role we play in there. So first, Metroscope is a technology. This is the technology that was developed at EDF R&D and that justified the potential for having a whole company built around it. And this technology is built around two bricks. The first one is digital twin. Of course, digital twin, very, very broad term. Everybody talks about it at the moment. For us, a digital twin is a representation of the process, of the physical process of a power plant. And this is a representation that should give a reference value, an expected behavior of the whole process of every single sensor data. You have a reference value. And this reference value is going to be compared to the real plant. So you have the digital twin and you have the real world twin, if you want. And the real world twin is going to tell you this number is going in this direction, this number is going in this direction. How do you make sense out of all these sensors going everywhere? First, you will compare them to the digital twin. But this is where, let's say, the human work stops, because you could potentially compare some sensor data to your reference value, but how do you make sense out of all these sensors data, which are not always exactly corresponding to the digital twin? And this is where the second brick comes in, the inferential engine. To be quite simple, this is an algorithm that Metroscope developed, which is patented actually. And the job of the inferential engine is to take all of the symptoms, all of the consequences, and to find the cause. So the fault that could explain all the symptoms that you see on the plant. And this is why the job of the Metroscope in the end is to produce a diagnosis. The output of the software is a scenario of fault, a combination of faults, of events happening on the plant that explain why it's behaving in such a way at such a time. So now, if we go into a bit more details of exactly what is a Metroscope digital twin, the first step is to have a nominal model. This is the model, the thermodynamical model, which tells you how should my plant run in perfect conditions, given a number of parameters, given the outside temperature, given the power that I receive from the steam generators. What does it look like? What does it should look like, sorry. And here, this is only the secondary loop of pressurized water reactors. We are not actually addressing primary cycle yet. But basically here, you have already a lot of components that you want to monitor. You have a lot of sensor data coming from these components. And in our model, you have a lot of physical equations explaining the relationship between all of these components. So the point of the nominal model is to tell you what should it look like. But then you also need an understanding of what is it going to look like if something goes wrong. And this is what we call the fault matrix. This is the list of all the fault modes. So for example, a leakage, for example, a fouling in some condenser that will reduce the coefficient of exchange, which will reduce the performance of the plant. So all of these fault modes, all of these fault signatures are basically the bricks, which will explain what is going on. And so moving on to the second brick, the inferential engine, its job is to provide an answer to all of the faults all of the symptoms going on. And in the end, the job of the inferential engine is to try out every combination of faults possible on the plant, which are physically consistent, meaning in any way it has to be consistent with thermodynamic rules, and it will provide the most likely, the most probable scenario of faults that explain the current symptom. This is the whole story that Metroscope is trying to build, thanks to the digital twin, thanks to the faults, and thanks to the inferential engine. But then all of this technology has to be usable on the power plant, because if you just keep this tool for some experts in a monitoring center, or maybe one thermal performance engineer on the plant, you're basically missing the point. The point of having such a solution that gives you an easy answer, or let's say a sensible answer to what is going on the plant, is also to act and to decide on top of these results. And this is why we have also a software. In the end, we are developing a software that gives you all the detections, all the failures going on at the plant, how much you're losing in terms of megawatts, and also how critical you should decide on some of these faults, because some of them are only related to performance, but some of them can also trigger some safety mechanisms, some nuclear safety mechanism, which means you have to track it quite closely. So in the end, Metroscope is a lot of technology bundled up into a software which is usable by people on the plant, but also people in a monitoring center at a corporate level when it comes to asset management. So this is all of these bricks that come together. So in a nutshell, this is three things: the technology, the approach, the software which is used on the plant. And this is everything that we are selling both to EDF, but also outside of EDF now. And moving on to the EDF example, this is, let's say, a story which goes against what we've heard before in terms of the innovation adoption curve. Metroscope, from the start, was an R&D project. It was not necessarily meant to be a business success. But the thing is, when you start with 56 reactors as your first customer, you're already covering more than 10% of the nuclear fleet worldwide. So that is a very, very strong start to the story of Metroscope. And actually, it took several years to equip all of these plants. The first pilot that was deployed was at Valluel, so in the north of France, in 2017. And the real full speed deployment started more in 2019 towards 2021. So it took roughly 3 years to deploy all of the French nuclear fleet. The last one being equipped was Bugey 5. And one key important piece of the story here is that it's not just about Metroscope. It's about a collective effort of EDF to deploy a new digital solution on its nuclear fleet. And this is why we had the support from two engineering divisions from Metroscope, for EDF, that provided modeling expertise and modeling capabilities. At the time in 2019, there were probably 10, 15 people at Metroscope. So realistically, the scale was just too big for a company. And we were supported by DTG, so Direction Technique Générale, as well as the CNEP, so Centre National d'Équipement de Production d'Électricité. So these two engineering divisions helped deploy Metroscope and are still involved into make sure that they maintain all of the digital twins, because there's 56 digital twins going in exploitation at the moment, and all of these digital twins have to be also updated, upgraded, and adapted because the plants are living. So if the digital twin is not an accurate representation of the actual plant, you lose the point of having a good reference. So DTG and the CNEP are still involved into making sure these digital twins are useful. And finally, also another ATT of EDF that was strongly involved and still is actually managing the project is UNI, so Unité d'Ingénierie en Exploitation. The point behind is that it's a collective effort. It's not just about Metroscope to onboard all of EDF DPN into this project. What are the results of this project? Where are we at the moment? The first thing we can say is that we've seen a wide adoption of the software across the sites and also at the fleet management level. We have now around a bit more than 300 users of Metroscope, and more than half of them are actually using it more than once per week. So it really shows that it has taken, we have some grit in the organization, and it shows that people actually see the interest. This is the best testimony of his Metroscope actually useful, where apparently at least 300 users think so. So that's a good confirmation of the value we're providing. And another really key aspect is that it's not just an expert tool. It's not just for a few experts in e-monitoring or thermal performance. 80% of the users share the results, share the diagnosis outside of their team. So it's really the point of saying, now we are opening the box. We are opening the box in terms of people can have an understanding of the state of the plant automatically, and we all share a single source of truth, if you want. The second thing we can say is that we already see a lot of interesting results, and DPN, EDF has now a better understanding of how much it's losing, because obviously there's always going to be some losses in terms of power, and what they can do to retrieve this power losses. And it translates into 220 unique faults that have been diagnosed in the nuclear French fleet in France. So that's actually a lot of detection of diagnosis that maybe the organization before would have not been able to make. And finally, a side effect that we see by having 18 power plants in France using the software is that they have a way to share their experience and their knowledge of faults. Basically, now we have more than 350 years of return of experience because the software has so many reactors for already a couple of years. And this is a huge amount of data that we have to give us a better understanding of how these plants are working and what's going wrong and what can be done better. And finally, we also see that plants are now talking to each other a lot more. They can exchange, they can share best practices, and this is really the direction that we want to give. And to conclude, this will be my last slide. The direction is now we want to have more collaboration. We see that there's a big benefit to have a Metroscope shared in the organization. And this is why we organized in Paris last December a meeting with all of the users so they can tell us also what they love about Metroscope, what they hate about Metroscope, and where it should go next. But really the point is to build a community of users that have the same reference frame, that understand the problems in the same way and can collaborate together. Another aspect we are focusing now is also fleet management, because in the end, the job is not just to make sure that each single plant is running well, but also to have a better overview, a better understanding of the common issues. I have a fleet of condensers which are deployed in France. How well are they performing? Is there some designs that are affected by some issues? I mean, we've seen some recent examples in France. This is the kind of issues that are addressed at a national level and not just at plant level. So we are also focusing efforts here. And finally, we are also working on improving the digital twins, the software itself, to be able to hunt even more megawatt losses. And one of our main axes of development is cooling towers, because we're not addressing them yet, and also integrating new faults in the software so that the basis of knowledge that we are building keeps growing and keeps helping the operators perform even better. So this is really the direction we're heading for. And actually, that would be it on my side. And I'm really glad to have your questions.
Thank you, François. Thank you for this very interesting presentation, which in some way show how to mix human expertise and data analysis, and how we can detect weak signal to make some predictions, and it's very interesting. I have some questions from Simon. Can you build digital twins for any kind of reactor?
Well, actually, since we are looking mostly at the secondary cycle, there's no limitation in itself. I mean, as long as we have access to the data, as long as we have access to enough historical data, sensor data, and piping and instrumentation diagrams, on paper, there's no limitation. It's more or less the same process everywhere. So now we are addressing PWRs as well as BWRs. We have a couple of projects ongoing. So yeah, on paper, you can address anything as long as it has a steam cycle, basically.
Okay. Another question, is this linked to probabilistic risk analysis at all?
Well, I don't think there's a direct link. Basically, the approach of Metroscope is to look at all of the data and having the algorithm running all of the potential scenarios that could go wrong and that would explain the best what is going on. So let's say we are not directly into predictive maintenance. For example, we're not trying to tell you at which time which equipment is going to fail. We are more into early detection. and giving enough information for operators to better undertake these problems. But I mean, I hope I answered the question clearly.
Okay, another question. To make a fault analysis of an equipment, are you focusing on the serialized item and to understand the asset focus on in-operation digital twin?
Well, basically, to understand the fault, what we will do is use the digital twin that we built. So the nominal model I was talking about is basically your playing field. And then to build a list of failures, we will stress the model. We will simulate the faults into the digital twin and see the output. So basically, this is a combination of the knowledge of Metroscope, of common faults on every component. And this is also the combination of faults that operators will communicate to us. So in the end, the fault metric is all of the expertise from Metroscope, from the clients, embedded into a list of signatures. But in the end, the process exactly is you stress the model, you see how it reacts, and this is your failure, basically. And this is also why in the future, as we learn, as we keep integrating new faults, the fault matrix is growing.
Okay, thank you. There are no other questions, but we are short in time. So now I give the floor to Jean-Eudes, and thanks again.
Yes, thanks very much. So the next use case will be presented by with two speakers. So we have Audrey CASTELEIRA from Framatome. Audrey has been working 14 years in Framatome and now working in the digital transformation on the business unit install base of Framatome. And we have Rodolphe Visdeloup from Siteflow, working at digital transformation project manager. And Rodolphe has a background in mechanical engineering and has been working across project and even international projects in different companies. I give you the floor for your presentation on this specific use case.
Thank you. So I'm going to start, and so hello everybody. So today's presentation will focus on the digital transformation of Framatome fields operation, and especially on operation done by the IBF business entity of Framatome. So IB for install base France business units, which is usually performing some maintenance, some modernization operation of the current nuclear power plants. So today, as you mentioned just before, will be two speakers. So I'm going to let maybe Audrey add some comments. So Audrey, if you want to add something, already said.
Thank you. Yes. Hello, everybody. So I'm Audrey CASTELEIRA, and I'm safety engineer and ergonomist. And as Jean-Eudes said, I'm the responsible for the change management package.
Okay, so on my side, so as already mentioned, I'm a delivery manager for Siteflow, which is a software editor, and so I've been lucky to carry out this project within Framatome. So prior to going deeper into the context of this project and the objective of this project, I'm going to speak a little bit about the Siteflow solution. So the Siteflow solution is the name of a company, but also a name of our main product. This product is a cloud-based software management service software, which is used to perform some complex operation, and it matches with the complex industry's requirements. So this tool is today used by 100% of the workforce, meaning that it connects the desk offices to the field operation workers. And what I can mention as well is that we are using two main applications, a web and a mobile application. So I'm going to let the end to Audrey, who will introduce this context of the project by speaking about this picture first.
Thank you, Rodolphe. So yes, this picture was taken at an establishment in Maubeuge during a phase of development. It concerns nuclear waste packaging activities. And we chose this picture because for now, 100% of these activities are now performed using Siteflow.
Thank you, Audrey. And I'm going to let you speak about the context of this common project.
Yes, concerning the context for Framatome, the digital side work package project belongs to its digital transformation global strategy. So the final goal to us is to have a connected worker to improve carrying out intervention. The digital transformation project is also a way to take major steps regarding data gathering and analysis. We want to improve our overall performance while leveraging our employees' skill on the field, which can be achieved by providing them the required data directly on site. So we reduce the amount of paper they need to deal with. And finally, these improvements help us meet with our clients' expectations and stay competitive by keeping up with technology advancements.
Maybe some other words regarding the context, Audrey?
Yeah, Framatome's goal is to simplify processes, not only by eliminating paper during intervention, but also to standardize our process so that they become more, so that they become more reliable in terms of quality and safety. We want our customers and partners to focus on useful data. In the retaking of nuclear power, new technologies are tools that we need in leverage in order to appeal more to younger generations, for example.
And so in this context, Audrey, can you explain us why you choose Siteflow?
We choose Siteflow for different reasons. First of all, we selected Siteflow because of their integration in our information system. Siteflow Universal Tool is leveraged by others actors and developed internally, which encourage us to pick up their solution. One of the main strengths of Siteflow is the vision provided to our on-site workers. In fact, the main philosophy of this tool is to provide the right information in the right time so that the worker follow a step-by-step process.
Okay, thank you, Audrey. So I'm going to just provide some words regarding the project milestone and scope. So that project that we started with Framatome IBF started in June 2020. I would say that our delivery team from a Siteflow point of view, I would say spent months among Framatome experts to know exactly the usual way to work and to design the process of tomorrow. As soon as we established this process of tomorrow, obviously we tested it a lot through on-site tests. So we went on nuclear power plants to adjust these processes and to adjust the organization and to validate this new organization. So that was, I would say, mainly 2 years work. And maybe one thing that we want to highlight here as well is the change management topic, because we're going to speak about this topic just after. So the change management topic has been identified since the beginning of the project as the main success factor of this project. And you can see now that even if we started the run phases in January 2022, Framatome chose to maintain a change management team in place to support the current deployment. So maybe to go further in this topic, I'm going to ask a new question to you, Audrey. Could you just explain to us how people are usually dealing with change?
Yeah, so this curve that we can see is very important in the change management. We can see all the states that the user is going to feel until the acceptance. With change comes resistance to change. The curve that you can see now is a model used to understand the stages of personal transition and organizational change. So it helped us to understand how people react or can react to change, so we can better help them make their own personal transition and make sure that they have all the support that they need.
Thank you. And can you explain us how basically you put this curve into application on the Framatome standpoint?
Yeah, so you could understand that with this kind of changement, there are a lot of feelings. So to deal with all this feeling, we built a change management plan based on 3 fundamentals: communication, training, and change workshop. We choose to work with all teams and all functions to guarantee their implication. A major information to highlight here is the absolute necessity to engage management in the project. Their engagement will be a major input to all levels of the engagement.
Thank you, Audrey. And maybe how we can make a link between change management and continuous improvement. Can you explain us how you deal with this?
Yes, of course. I introduced before change management has always been a major success factor to deal with since the beginning of the project. Framatome and Siteflow also work together to apply a continuous approach in the project, and they are still working together toward this direction. We choose to make different phases of training to test the solution with our field workers. The goal was to be sure that the product was compliant with the user's need on the field. Our strategy of deployment was to deploy first simple and recurrent operation for reactive feedback and mobilize teams. And after, we will continue with the second step with complex operations to integrate at the final all our realization with the digital site work package.
Okay, and something that maybe I can highlight here, that Framatome and Siteflow really grew up together by using what we call here the feedback culture. So at the end of every on-site test, at the end of every workshop that we have done together, we took the time to share some feedbacks. So that was a really interesting insight for Framatome to, I would say, make the processes better, make the organization better. And on the other side, for us, on the Siteflow point of view, it was really, really helpful to make our product better as well. And so going to the next slide, maybe, Audrey, could you just explain to us what did you achieve through this project?
Yes, I can share with you some results. Since 2019, 200 workers use digital site work package. And 3 years after, to secure the deployment, we began all first activities by paper and digital in the same times. In these years, we will able to start the full digital phase. So for each deployment, we make feedback, and now we had a lot. And to give an example, the mobile solution was rated 8 out of 10 by field workers. So it was important to know this information. As a reminder, one of the main objectives of the project was to connect the field worker and the method engineer. And that is something we achieved.
And to go further and to let you breathe a little bit, Audrey, I will add some benefits that we observed as well. This project was also the occasion to make different business lines speaking together. So some methods engineers from Framatome that they used to work separately, we had the occasion through this project to make them speak. And that was a main input for them and for us to homogenize the processes. What we could observe as well through first application of Siteflow on the field is that there was less field workers errors. The data is circulating in a better way. Reporting is also facilitated. And we can highlight as well that at the end of the operation, Siteflow is as well a substantial gain in time regarding the completion report, which is done in a few clicks using the application. So yes. Go ahead, Audrey, sorry.
No problem. And to conclude by just to say that by integrating change management at early stages of the project, we were able to anticipate problems and adapt our communication and action depending on user, which amplified unity. So Siteflow supported us during our digital transformation and provided training, and we could quickly understand and work through new habits. So this collaboration was crucial to make such a big changement happen.
And so now if you get some question, please go ahead.
Yes, thank you very much for that very interesting project and feedback. Some question indeed. One question about change, human factor. Did you include human factor experts in the software development, I guess?
In Siteflow or in Framatome?
This is the question, so I guess in the project, I understand in development, so maybe in software development, so I guess in Siteflow, but I'm not sure.
Okay.
I'm not sure to perfectly understand the question, and I'm going to try to answer. Today we have, I would say, specific UX, UX UI designer with us to understand how people are usually dealing with application and new applications. So yes, we include, I would say, human factors in our development, and it's we have daily interactions with our design team, obviously, to improve our product.
I think that was about UX design indeed. Another question, and we have to go quickly, was about the change management framework or method. Did you adopt a method like Atkins? I don't know what it is basically, but I guess it's some standard method in change management. Yeah.
Oh, for the change management, we built a change management plan, not with this method. We adapt our method with our users. So we had like 30 referents, field workers. So we worked during all the process with them, and we adapt our workshop and our communication, our action with their feedbacks. And with Siteflow also, we share our information to build our change management plan.
Yes, thank you. And last question from Claude. As soon as you replace human action by digitally assisted process, people involvement or attention may drop down. Did you experiment this in the project, and how did you face that issue?
I'm afraid to not understand the question.
I think the question is, if you replace somehow the human by, or the human is being assisted by the machine, by the process, the involvement in the safety process, let's say, may drop down a bit. So did you face that situation?
No, we don't see this reaction. We carry about this this action, but all the feedback are almost good. So field workers say that they are not alone, and the device grow up their way of work. So it was not a thing that we can see. I don't know if Rodolphe can.
No, I agree with that, and I will say that I mean the human action are not replaced by the process. So I mean we are helping obviously the field workers to work and to, I would say, decrease the non-added value actions for them, but the main action they are still responsible of it, and they have still to be like a lot involved to do their work. So I mean in the past we didn't experiment this kind of situation.
Thank you. Yes, clear. Thank you very much. Back to you, Jean-Bernard, for the last presentation.
Okay, thank you. In terms of digital deployment, as Samuel said, we cannot foresee digital deployment without standards and norms. And Samuel said that the decision made by the British government about the norm to follow is clearly an accelerator. So we decided, we selected one presentation dedicated to norms and standards in the digital. And this presentation will be made by Christophe Mouton. Christophe is graduated in Telecom Sud Paris. He joined the EDF in 2001, and he is currently IT expert for data standardization for the new nuclear engineering division at EDF. He is also member of several technical and scientific bodies, and especially at ISO Technical Committee number 184 about automation system. And at the standardization committee of that technical committee, the standardization committee number 4 for industrial data. So now the challenge for Christophe is to be on time. It's always a challenge for the last one. But Christophe, the floor is yours.
Thank you so much, Jean-Bernard. So let's start our journey. So I will try to describe you what happened these last 3 years. Here you have a screenshot of a series of resolutions that was taken by the standardization bodies that Jean-Bernard had just highlighted. So the one dedicated at ISO about industrial data. So end of November 2019, it was decided to create another group of experts to draft what could be specification for a nuclear digital ecosystem. So very quickly, TC184, it's industrial automation system integration. You will find a whole bunch of standards dedicated to how IT could help industry. So it's very focused on how digital transformation could help the industries. Inside TC184, you have subcommittees, you have the whole list here, you have some working groups too. You will notice that digital twin is in a good place too, but here we will focus on SC4. So SC4, it's industrial data. In the blue cloud here, you have the different main ISO standards that were developed. You have some of them related to digital mockup, others for how you describe your data, and also your product. So product characteristics, product classification, product libraries, of course, industrial terminology, and data quality. Industrial data quality, it's ISO 8000. It's not ISO 9000, it's 8000 for data. So you have also some very interesting topic on how you can visualize your digital mockup. So it's quite challenging. And you have some KPI below. So 791, it's a number of published ISO standards in this only subcommittee. You have 38 under development. And I will just show you the number of countries. So in blue, you have the participating countries. So it's countries who can develop and ballot and vote during the ballot, the standards. And in orange, you have the observing countries. So you have a kind of well representation of industrial countries. In this resolution that I introduced in my first, I will say, slide, more or less, you have the text of the introduction and the scope of what we have to do in this other group. So we have to collect state-of-the-art industrial needs and to be in touch with other stakeholders to discern, to describe what are the, I will say, the application of current standards for data, and also if there are some gaps, how we can fill them and propose new work items for developing new standards. So in the resolution, you have here a list of names that were provided. So mine is already known, but for the others, you have some protection for personal information. So I have to blind it. But something that you can notice, it's at the end, at the bottom of the text, it's that you have another ISO committee that is mentioned here. And I will say that it's the one that I will present now. It's another committee dedicated this time to our nuclear topic, nuclear energy, nuclear technologies, and radiological protection. So there are also a lot of standards. They are working with 25 participating countries. So you have here again in blue on this map all the participating countries who are able to vote during the ballots for developing these standards and validate them and publish them. And in orange, you have the observing countries. So now the main topic, how we can succeed in building a digital nuclear ecosystem. Oh, yeah, this is too much, sorry. But here you have the, I would like to pay tribute first to a standard that was developed for oil and gas first, oil and gas interoperability, now asset-intensive industrial interoperability. But here you have the main definition for digital. What is a digital ecosystem? It's a distributed, adaptive, open source technical system with properties of self-organization, scalability, and sustainability inspired from natural ecosystem. So quite challenging, I will say. So it's not totally new that we want for our nuclear industry to cover several use cases thanks to standards. And here I would like to remember that IAEA has worked on what is a plant information model for design knowledge management. And you will have, during when we will communicate the presentation, you will have some URLs about a presentation of this work and also the final report that was published in 2020. So I will say the conclusion was not fully optimistic or conclusive, but I could say that we have today a combination of different standards that could be applied to our industry. So more or less, our standards to transmit or exchange data are based on 3 pillars. You need a vocabulary, so terminology. You need a way to transmit them, so kind of digital storage, formats, flow, data flow, and so on, but with a syntax and grammar to describe them, and also how you will use them. So you have a process to relate to terminology and digital storage. And if you look at a breakdown structure of what is more or less our power plant installation, so from the country to the final, I would say, pipe or valve, some piping system, you will see that you can apply some very well-known standards like CTGML for geographical information system. You have one that was received by our colleagues from oil and gas industry, so ISO 15926, on how you can integrate the data for your installation. You have some of them that are coming from the AEC sector, so the construction sector, 16739 IFC, very well known. Another one from the same domain related to building services, so how you can describe your services, so ventilation, heat, and water and so on, and how you can simulate them. It's very challenging, very interesting. All your parts, you can describe them in product libraries. So you have a first list of them here. And for system modeling, you have the very high level with the one that is the most known, the most well done, 15288. You have other one at ISO IEC, which describes some structuring principles, breakdown structure, and reference designation. So here you have one reference. And the final one, which is very, currently, I think it's still at ISO Central Secretariat for publication, but it's very fresh. It's one related to ISO 15926, part 11, edition 2, that describe a way to relate your system engineering requirement to your final installation description. And of course, you can enter the various ways that you can describe your geometry things. So 2D, so for PNIDs, and also for 3D, our famous 3D models, 3D mockup. So let's continue how we proceed to start this work. So it was decided middle of November 2019, and we'd start really the work beginning of January 2020. So before the nice events that we just, I hope so, we go through. So that led to us to manage 34 virtual meetings with 15 experts from several countries, China, France, Korea, Japan, Netherlands, United Kingdom, and Sweden. with the various, I will say, backgrounds for all these experts. So from nuclear power utilities, national nuclear associations, software vendors, IT engineering consultants, academics too. We worked with national surveys, so we sent some questions to the different countries to collect their industrial state of art, digital challenges, their own standardization needs and challenges. And we also attend some presentations, for example, from very recent projects in the Netherlands, which were using some oil and gas process industry standards, but also from the construction sector. And that led also some proposal from one by Korea about how you can describe in a standard nuclear digital ecosystem framework. So it's very recent. The project was proposed last summer and it was accepted, and the project has started, and they have 3 years to achieve so this standard.
Christophe,
so sorry.
I'm so sorry, but if you could quickly, please.
Yeah, I will jump more
so
or less
sorry,
to the conclusion.
Sorry
it's
for
quite
that.
sad, but I see. So here you have some examples, but we don't have enough time to process them. I will say that the good news is that this draft technical report is now delivered to the committee, and we are working with TC85 on to. I would say we have worked, with TC85 to collect all the topics that perhaps we would like to improve in this document. And I will say that we are quite happy because we will submit this document for balloting in the next weeks. We hope, of course, that the ballot will be successful and that the publication will follow this year. And we have established very nice relationship with our colleagues from TC85, so the colleagues from nuclear, and that could lead us to have a better understanding on how IT, all our knowledge about industrial standard could help them to build this digital ecosystem for nuclear. So you are very welcome to get on board, and feel free to contact your national standardization body to join the effort. You have the list here of ISO members, so feel free to contact them, and we are very happy to welcome new members, new experts in our team. Thank you so much.
Okay, thank you very much, Christophe, for your best efforts in reaching the limit. I have just one comment, and if you could just answer fast for the people to well understand the scope, because the automation system for me is at the lowest level of the, let's say, IT architecture. How high these norms are dealing with? Are we at the SCADA level or even higher?
You cover everything. In fact, it's how digital could help industry. So you can, of course, have very high levels monitoring for supervision system. So yes, SCADA, why not? Of course, you have also how you can describe your process for manufacturing. So we have series of standards that could help manufacturing industry, but also process industry to describe their workflows and so on. And you can attach on this workflow, which data you required and for which purpose. So here, very quickly, thank you for your question. I can show you the summary of the report. So you can see very applied, I will say, topics like configuration management, requirements management, breakdown structure management, reference data management, but also how IT could help in the way that you can have some, I will say, some helps to model your properties, model your process, model your semantic and for your reference data, all your knowledge, how you will process the quality of data, the famous digital twin, how you will also work on long-term archiving, because we are dealing with digital, so how you will process long-term archiving. So yes, okay. We cover all of that. Yeah, thank you.
Okay, thank you so much, Christophe. Now I give the floor to Jean-Eudes for the conclusion.
Yes, there is one question, by the way, which is if you can share the number of this report, which I think you can do, Christophe. Then, so for the conclusion, first of all, again, thanks to all the presenters for their presentation. Thanks also to the number of participants that we had, because we were almost more than 100 participants on this conference today, so quite successful in terms of audience. A very quick takeaway on my side, because we are running out of time. In fact, I believe, listening to the presentation, that in fact, the benefits of digitalization for the nuclear industry are quite clear, although, as we said, they are sometimes not easy to demonstrate. And what I think is quite interesting in the use cases that were demonstrated compared to even the last edition of Index 4 years ago is that we have some projects that are being deployed, and we are talking number of users. I think that was what I took some notes on the manufacturing surveillance project within EDF. We are talking about 400 staff on board. The Metroscope solution for predictive maintenance, we are talking about 300 users. The Siteflow use case with Framatome, we are talking about 200 users connected. So I think this is showing that some projects are going now, maybe not at scale completely, but are being deployed, which I think is quite interesting in terms of digital deployment, which is the purpose of this discussion. And from Antonio landscape and from the presentation of Sam on SNC Lavalin side, I think we have seen that there is some challenges which are maybe specific to the nuclear industry in terms of, let's say, sovereign concerns or cybersecurity, which maybe can explain that nuclear is maybe behind some sectors. But again, we can see from the project deployment that we know, I believe, what are the conditions to unlock and to unlock the roadblocks. Let's say the quality standard can be one, the change management. Of course, the regulation body can be supporting that. So I think it's a positive trend that we can see from those presentations in terms of digitalization of our industry. The next presentation, or the next, I would say, conference from Index continue next week with roundtables on critical industries, and also roundtable, or I would say keynotes on artificial intelligence in nuclear industry. So please continue to look into Sfen website to go ahead with the next Index conference. Again, thank you everybody, and I think now we can close today's session.
Thank you.